Okay, so gonna hit the timer. Hello everyone. Um, Embedded Monkey here, and I guess I should introduce myself on that day zero of Embedded Adventure journey. Um, Actually, I've been studying embedded systems for like about 2 weeks, maybe a little more for now. But this is the first day that I decided to record, and um, I guess I should tell you a little bit more about myself and why I'm doing it. What does this timer mean right here, and so on, so on. So, um, to begin with, um, I'm a C++ programmer. I have a 1 year experience working as a software engineer, and currently I am working as a compiler engineer at. I won't tell you the company, but I've been working there for more than a year. Also, I'm studying at university and actually finish it the next year. So I'm preparing my bachelor diploma. I guess I I said it right in English, because English is not my native language. Um, but nevertheless, um, nevertheless, why am I actually doing that thing? Why am I actually decided to learn embedded systems? So, first of all, um, uh, as many of many of you young guys who are studying at college, especially at computer science, we don't really know which field is much more appropriate for us. Web development, AI, maybe compiler engineering, maybe digital circuit design. There are plenty of ways, there are plenty of opportunities that you can take, and the thing is that I always thought that this hardware thing, so um, the the circuits, the different microprocessors, that's not my cup of tea. And that wasn't until this year, because we had a wonderful course at our university about digital circuit design, where we were developing our own CPU. And I was very excited. Actually, that was a very interesting course. Besides some of its uh, some of its objective disadvantages, because we were programming in program that was issued like in 2002 or something like that. But nevertheless, the course was actually pretty good, and especially I've got interested in how the software communicates with hardware, because that's pretty interesting if you think. We usually we think about software and hardware as separate paths. Yeah, you can be either a software engineer who develops web apps, or AI, um, or just desktop applications, and so on and so on. Or you are a hardware guy who develops the digital circuits, who verify them, who maybe do some assembly code, and so on and so on. But we don't think that there is a path in the middle. And this is embedded systems. So this actually got me curious, because I both interested in software and hardware at the same time. So I decided, why not to try both? So I guess this is my actual manifesto for that embedded adventure. Um, Main goals are probably first one to just like firstly, besides like any material goals, I want to just dive deep into this area and understand whether I really like it or whether it just like temporarily passion. I currently don't know. I remind you, I'm just 2 weeks into this, so I'm not very experienced. And I guess two main goals are to create a cool project that I really enjoy. I currently don't know which project I will do. I have some ideas, but maybe you'll suggest something, guys. Maybe I will describe them. And secondly, to find a new job in this area, because currently I guess I'm not really interested in compiler engineering anymore. But well, we'll see. We'll see. Currently, I just want to dive deep into this area and learn more about embedded systems and do some cool stuff. If you want to check like the full version of my manifesto of my different thoughts, you can subscribe to my Telegram channel. I will leave a link in the description. There are also some materials that I use right here that I collect. They're actually right here. So I have a bunch of links, some roadmaps, different, absolutely different channels, sites, web resources. So I gather them here and I want to share them as well. Also, I have some conspect materials, like my notes. Yep. I also have some notes. Let me show you. Oh, here it is. So I also upload some notes right here. I also share them freely in my Telegram channel, so if you want, you can just see what I'm doing there. I don't guarantee you that my actual explanation is right. For example, here, the flashing process, I really just was exploring that. That was actually my my interpretation of what ChatGPT gave me, because ChatGPT is a wonderful way to learn things. You just ask questions, you get more and more information, you verify that through other sources, etc., etc. So probably that's not the 100% like correct info, but you probably can check this out. Maybe you'll like it. Why not? Okay, so moving on, let's go and see what I have done right here and right now. Currently, the current progress is I have blinked an LED in 3 different ways. Yo, the first way I've picked was probably one of the hardest way. I've chose to do that using the one more thing. Sorry, one more thing. I also have a GitHub where I have all the code that I will be writing here. So if you'll want to check the code of this like LED blink, I don't know actually if you are interested in LED blink, but if there will be like more code, you can see it here. I will also leave a link in the description so you can check this out. So back to what I have done, back to the current progress. Currently, I've blinked an LED in 3 different ways. Firstly, yeah, of course, hello monkeys, hello embedded monkeys. I've done it with the Let's See controller in the ESP32. And that's actually gave me a lot of understanding of how the pulse width modulation works, because the pulse width modulation is fundamental to is a fundamental principle to control, for example, speed of motor or the brightness of LED. So when I firstly noted that PWM is actually a thing, I decided to go this way, and this was very hard to understand what all these fields of the structure means, but actually the source number one that actually helped me was there was official papers. Yep. So the number one source that actually helped me a lot was the I guess the technical reference manual. Yep. And I've got a lot of info right here about the Let's See controller. Yep. So that was actually a pretty good explanation right here how it works. Like that there are like actually 8 channels that can work in 2 modes: the high speed mode, the low speed mode, what are they differ, etc, etc. I won't get into the details right now, but for the curious ones how I've done that, I just was looking in this documentation and trying to understand how it works. The second way how I blanked an LED was the bare metal, of course. Yeah, bare metal, that's actually the way. That's actually how the embedded works under the hood. It's just writing to some addresses, it's reading from those addresses, etc, etc. So that was actually pretty hard, because nevertheless I know how the like addresses works, but this is the whole different world. This is an ESP32. It's a microcontroller. It has a different. It has a like the memory mapping is different here. Well, I probably won't. I won't be able to find that, but oh yeah. So these are their register layout. So usually they describe it like this. So I just found the description how to output something to the GPIO, and I found the register in this documentation, and just mapped those addresses of those registers here, and was just modifying and masking them with this with the different logical operations. Yep. Okay, and the third way, of course, that was the last way that I tried. That is the most simplest way here. It's just the resetting a pin, setting its direction to output, then setting the level to 1, and then setting it to 0. Okay, so that's it. That's my current progress. I've done the LED blinking in 3 ways, and more. I've bought some different equipment that I'll show you right now. Let me see. Okay, I gotta turn off the screen. Yep. So here's my table. I'm probably gonna move from here because there is like very small space for prototyping something, so I have a separate table that I will probably move to. Currently, I guess this is enough. So what equipment have I bought? I have bought some jumping wires. They're actually pretty cheap and pretty unreliable, so they are actually stinked with some plastic smell, so they're not very reliable, but currently the 2 I have placed on the breadboard, they worked perfectly, so I guess we can use it with some some carefully, yeah. Also, I have bought some resistors with different resistance levels. Here, for example, I have resistors with resistance of, as you can see, oh, I don't know, can you? 220 ohms. Sorry for the shitty webcam. Unfortunately, that's not very good. Also, I bought some LEDs. Yep, LEDs with different colors. Got a USB cable to flash the binaries to the ESP32 microcontroller. Of course, I got the breadboard. Got the breadboard right here. As you can see, I've assembled a very simple circuit right here. I've connected the D2 pinout to the resistor, then the resistor goes to LED, and then the black wire goes from the LED to the ground. So that's basically a circuit for blinking the red LED. I actually posted the working of this circuit in my Telegram channel, so if you're interested, you can take a look there. Oh shit. Actually, the problem with the ESP32 that it has a very, very thick pins, as you can see. It doesn't fully goes into the breadboard, but when I was looking for the solution of this problem, I haven't found anything but the advice to buy the like extra connectors to those pins that were actually thinner. So I decided I was looking on the internet where I can buy them, because I'm not in the US, and the link was to the store in the US. So that was actually pretty disappointing. But then I connected and it all worked. So I guess that's not a big deal that they are not fully into that. I don't know, actually. It works, so it's good. Also, I have a knife. Knife to maybe to cut some of those things, like not this way, but more like this way, to separate one wire. And these I don't know how to call it, like, this is basically a multi-tool to maybe adjust something, some small parts right here. So pretty useful, handy thing. Also, I got the power line that I have cut it off in the very barbarian way. As you can see, it has a broken isolation. Yeah, broken isolation here. So it's extremely unsafe to use. I probably won't use it. I'll better buy the second breadboard. And also, the reason why I need the second breadboard is probably because the ESP32 is, well, it occupies almost all of the breadboard rows. Like, this is a power line, and we got only one row left, so I probably will need the second breadboard for more serious projects. But currently, that's enough. And also some notes. I have already shown what I write in those notes on the Google Drive, so that's it. That's all I have. So, basically it. And what I want to do now, I got the idea of the project, and I'm gonna show you it. Well, we're gonna develop it right now. The thing is, I want to do something both simple and entertaining in the same way. So I want to make the remote control of the LEDs. So let's imagine we have some ESP32 here. Yep. And and I want to blink the LEDs remotely. So basically, I will the project that I will be doing is just basically the IoT field, Internet of Things, because we will be remotely controlling the LEDs. Yep. The thing is that this project is recommended by most like embedded YouTubers because it's both simple and it can teach you to do some Wi-Fi stuff, I guess. So yes, to connect ESP32 to Wi-Fi, which is pretty interesting how it is done. Both on the low level and via the ESP-IDF framework. So I probably will try it. Yep. Okay. Actually, I have a big question. Which GPIOs I can use for blinking an LED? Like besides the GPIO2, which I have already used, which GPIOs are suitable for blinking or for connecting any other peripherals? That's actually interesting. Let me see. 32 pinout. Okay, let's check these. Oh, by the way, that's pretty good site. So looking here, what do we get? Okay, so GPIO 2. Well, that's actually the chip. I want to see the. I want to see more like the ESP32, yeah, DevKit V1 pinout. Because the ESP32 is basically a chip, it's not the board itself. And the board is a chip with a bunch of peripherals, buttons to reset the flash, reset the RAM, and to enter bootloader mode. I'm not really sure what this button does, but I hope that's like for entering a bootloader mode. By the way, if you guys know how the ESP32 executes code, I would definitely like you to comment that shit, but because I'm not really sure how it does work. I was trying to understand it, but with not very successfully. Okay, so I guess if we output from D2 and it's analog, we go to the GPIO2. We probably also can use the D4 output because it will be, like, I'll just switch quickly here. Like if you can see. Oh, you can't. Yep. Damn, I should buy a better webcam right here because that's. I can't really see that. Okay, so I have this row free and this row occupied. So I can use only pinouts on this side. Or I should buy the second breadboard, but not today. So probably I will stick to... well, I definitely can't use the D4 because it's free, and my board also have the next D16. And I don't have here the D16. Let's see where it is. Well, I guess this signature looks like D16. I don't know. Okay. Well, seems familiar. And this has an output for GPIO 5. So definitely we can, okay, I probably should find another picture because it's not very, it doesn't have a good quality. Let's see this one. Oh no, that was D18. Why I have D16? I literally have D16. Maybe I have the wrong board. No. Okay, that's actually strange because, you know, the board that I bought, I can show you the model, the exact model. Shit, man, I'm going to the Russian resource. Okay. Yeah, I'm gonna show you the, 1 second. Okay. I mean, you're definitely grateful that you don't see the recommendation page of Russian web market. Yeah, so it's called the DevKit V1 with the Type C. So I googled it right. Let's get back to the screen. So DevKit V1. So we have a GPIO2 from the D2. We can output the GPIO4 from D4. And okay, which GPIOs have the same property as the GPIO2? Like, why are they yellow? Is because they are analog or digital or something like that? Well, I don't really know. Like D5. Let's check the D5 maybe. Okay. Okay, D2 and D4, I can use them definitely, but the D5, can't really find it here. There is no D5. Okay, okay. And do I have a D5 here? Let me check. Yeah, I have the D5 actually. I have D2, D4, then it goes D16. I don't have these RX2 and TX2. Then I have the D16, D17, and then D5. So I guess I can occupy the D2, D4, and D5. Okay. sounds good. So probably I can make a simple program here. You know, let us simplify a bit. Let us make a traffic light. Yeah, let's firstly make a traffic light. So we have three LEDs which blink like red, then yellow, then green. Yep. I guess it's better to start with that. I hate Visual Studio Code, to be honest. Well, I hope you guys will be okay with my hands here, because the web camera is like down here, and I have a keyboard like almost on the level of the web camera. It's just integrated in my laptop, so I can do nothing about it, sorry. LED. Now let us call it just traffic light. Oh no. It's just, well, we should create it with the ESP32 environment. So let us open the ESP32 environment firstly. Yep. Okay, I will just. I hope you can hear me, guys, well, because I just push the microphone to the left. Alright. So oh shit, that's in the disk D. What the okay. Embedded adventure. And let's create the project. Create. Okay, I haven't remembered. It's not. Create project. Okay, let's create it. Whoa. Create project. Traffic light. Okay, here we go. Traffic light. So we have a CMake list file to just build this up, and we also have the basic app main function here. I'm probably gonna wrap the simple well, of course, these ways to blink an LED are actually pretty cool. I'm not gonna lie, but the simplest way is this one, right? Well, let us think. Does the traffic light needs brightness regulation? So, do we need like the do we need to change the brightness of red or yellow or green, or we just need to sequentially switch them? Well, I guess we don't really see that the traffic light change in brightness with like somehow. So probably we're gonna take the simplest way here. Yep. So I just see what I want to include here. Damn, quite a lot. Quite a lot I have to include. I guess the GPIO will be the thing that I only need. As far as I remember, those are in the GPIO driver. So let us make the separate module. I guess like let it call just traffic utils. Yep. And make some function to blink an LED. Do we need to return anything? Well, I guess the only thing we need is to reset the pin, set the direction, and set the level. We can also use the state machine. So like if it's turned on, turned off, etc. But I guess this like over complicated. We're probably gonna need it in the future, but currently no. So let's also make some. Okay, okay. GPIO on. Well, you know, we can do this without function. Okay, currently, let's just make it in the monkey way, the monkeyest way possible. Let's just make the yeah, let's just make it with macros. Yep. So we're gonna have a red one. Red one is well, let's make it in the D2. Why not? Red GPIO will be 2. So the yellow GPIO will be D4, and the green GPIO will be D5. Yep, D5 perfectly. Oh, actually no. No. Oh, or well, I want to know what these colors mean. What does these colors mean? Because these ones are yellow, these ones are purple, this one is yellow. They both is derivative from the original created by the Secretary of State website. They also have provided detailed explanation for each pin. You can check. Yeah, let's check this. The original one. Shit. Oh no, I'm so concerned about my privacy. Oh my god. Oh, yeah. Let's download it. Oh, so this one means that they are GPIO pins simply. So D2, D4, and D5 are basically equivalent. Yep. And we can use them freely. What the ADC inputs? Oh, damn. I guess we actually need the ADC. We can't use the D5 because it doesn't have ADC. ADC is the thing that converts analog to digital signal, as far as I know. I haven't really remember from the electronic course how they work, but probably we do need them. Okay, so well, I can use the D15 instead. Yep. So I have a D4, D2, and D15, so I can use GPIO2, GPIO4, and GPIO15 respectively. Okay, let's use it. So green will be, yeah, let's order them by the way. Like the D4 red, this will be red, yellow will be second, and green will be 15. Because that's how they relate it on, like, order it on the board. Like, shit. on this side those three pins, red, yellow and green. That's how you use them. Okay, now let's reset them. GPIO reset pin. Let's reset the the green. Okay. And of course we should also set the GPIO set mode, or what, like set direction. Here we go. Set direction for the red GPIO to the GPIO mode output. Yeah, and we're gonna do it for all of them. Yellow, green. Okay, and let's make a loop. Let's think how it's usually done. Yeah, so firstly we want to get the, let us see how the traffic lights work in general. Like the first thing, the red is on for several seconds, then it turns off, and yellow immediately turns on for a short time, and then green turns on for several seconds. So let's maybe define some number of seconds that we'll need. Let's say there will be some red time, and red time will be, for example, 5 seconds. Then will be yellow time, and yellow time will be like 2 seconds, and then will be the green time, which we can actually set just to 5 seconds as well. So let's make a loop. So first of all, let's set pin red GPIO to 1. Then we gonna use the, I need the RTOS function to make a delay. I'm not really into RTOS right now, but we definitely should I should learn a bit more about it, because the RTOS is actually also a fundamental thing in a embedded world. Yep. Okay. So set the pin, then let's use the vtask delay for the red time. But we should divide it by some constant, as far as I remember. Port tick period milliseconds. Yeah, because the vtask delay is for the number of ticks, not the number of seconds, and that's how we calculate the number of ticks that we need. Okay. By the way, I guess I just messed some out. Messed the name of the function, GPIO set level. Okay. let it be like this. So then we are turning the red GPIO off, turn it 0, and immediately turning on the yellow GPIO. Yep. VTask delay. Yellow tone. Okay. Better copy this to just speed up the process. Yeah. Okay, then we set the yellow GPIO off. And immediately turning on the green GPIO and make the delay. I know this code is pretty shitty actually, because no functions, no anything, just, well, we need just to play around a little bit before we get before we create actual project with controlling LEDs remotely. I just want to use a little bit of this. Yep. So we turn off, turn on, turn off, turn on. Yep. Sounds good, but we don't turn off the green one. We actually have to do that afterwards. Yep. So let's try and build it. Let's connect the ESP32. Okay, let's firstly build it. Maybe we should debug it. Okay. IDF.py. Guess there was a build command. Oh, I hope this won't last for minutes, because last time it was like, it was installing some dependencies and it was pretty long configuration process. Yeah, oh no. Okay, so let's just firstly, while it is building, let's switch to the table. I'm gonna make this circuit. 1 second. Okay, so let's build a circuit. I guess that, oh, let's firstly make the schema. Well, we don't really need the schema. Well, I just imagine we need a resistor for each LED, and we need to connect them to D4, D2, and D15. So that's actually will be pretty simple. I'm not really the electronic circuit designer. I actually have the E grade for the electronic course. I've passed it like last year, and I have the E. You know, the that's like satisfactory mark. I don't know, but it's not very good. So on the primitive level, we'll have the resistor. Yep. We'll have the resistor. Here we'll have an LED. LED. How the LED looks like, by the way, on the schema. LED schema. Oh yeah, I remember it. Yeah. Well, we can probably just use this image. Yeah, I remember that, right? Okay. So we're gonna have one LED. Then why it is so big? I want to make it like more, right? Maybe I have something here like LED. No. Oh yeah. Yeah, LED, 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 LED. Yeah, this one. Perfect. So we'll have an LED right here. We'll have 3 of them. One, and the third one also here. Here will be our ESP32. And let's imagine we created some pinouts on this diagram. I don't know how to actually draw them, but let's imagine this one is like, for example, this will be a D4, yeah, D4. Like D4. Yeah, they will have a pinout for a D2. And D15, of course. So, red, yellow, green. Then we'll let's imagine there will be. Damn. By the way, we have only one ground. Well, I guess we'll need a power line here. So we'll have a power line. This will be a GND. Like a. And we'll have a pinout for GND here. Yep. GND. And I probably will connect them something like that. So I will connect D4 to here. Oh, and a very messy schema. Like that. Also, let's actually move power line there. I guess it will be more appropriate to place it there, because we'll have a very messed schema in the downside of our diagram. Okay. Oh no, it's not orthogonal to this line, actually. Yep. No, please. Yeah, here we go. Okay. And let us also pick this one here. Okay. Sure. Oh my god. That's why I don't like electronic design, because that's actually very hard. But actually it's a part of embedded systems, so I probably should just learn it a little bit more. By the way, what is with the... Oh, it has built, by the way, successfully. Okay, nevertheless, we still need to make a circuit. So let us continue. Okay, but let me see one more. So, project build complete. Yep. So everything was successful. No errors. Wow. That's cool. That's cool. So let's connect the LEDs to the ground. Well, actually, the power line consists of 2 separate things, like the positive and negative, like we can see right here. Yeah. So, damn, very awful webcam. Oh, so you, no, here. Yeah, you can see. right here, plus and minus signs. So it has like two rows, one for the positive and one for the negative. And I'm gonna just make the same thing on the diagram. Well, let's assume that this one is positive. Yep, this one is positive. Oh my goodness. This one is positive, and this one is negative. Okay, so it will go to the negative line, of course. Well, I know it's not very accurate. It's not very accurate. Yep. By the way, like, oh my goodness. Okay, we almost finished. I will talk a bit about it a little bit later. Let's prolong the. Oh no. Okay. That's why I hate drawing diagrams as well. Especially block diagrams, but this one doesn't have any like restrictions, like government standards, etc. This one is actually drawn freely. And the last thing we should do is connect the negative power line to the G&D pinout. Actually, I don't know how the G&D can have a pinout. Like we should definitely have some isolation there. Like probably we could have just made some isolative material like wood or something else and just put the wires there. I don't know. I'm not very good specialist here. I should definitely. Read a bit more about electronic design. Yeah, but the schema will be something like that. I'll just. By the way, I'll save it. It's beautiful. Like traffic light. Traffic light circuit. Here we go. Google Drive, nah, GitHub. I'll probably save it to my GitHub, but later I'll save it to the device, right? Yeah. Currently I'll save it to the device. Here we go. Okay, so let's try to assemble it quickly if we can. Yep. So probably the first thing I need is to get rid of those, because it's like was the old circuit, but not from this LED because it is red. It's appropriate for us to use it. Okay. Okay, clean breadboard, beautiful. Let's put this one here. We also will need like 2 more resistors. So yeah, by the way, I'm gonna use our knife. Let's go. You know, let's use scissors. Scissors here. Okay. Here we go. Here we go. Okay. Shit, the timer. Damn. Okay. I just probably will stop it here. Oh my gosh. Okay, so I guess it's time to explain why, probably we're gonna finish the circuit next time, tomorrow, I hope. And the thing is, why am I working by the timer? Is because, you know, I have a lot of things that I'm obligated to do. So I have a university, I have a part-time job, have a lot of things, and the only thing how I can actually pursue my passion with embedded systems is to work for 1 hour every day. So not less, but not more. And the key is that I'm doing it every day, and I have been doing it every day for past 2 weeks. And I hope this consistent principle will help me to succeed in this area. That's not about actually the content. I would have finished this circuit, but for me, consistency is key. So I work for 1 hour, but do it every day. As for the embedded systems, and I guess I'm not the only one. I guess there are plenty of students who are also who not only study the computer science, who also work in for some company as a part-time or even a full-time job, and they don't have time for any of the any of things they are passionate about. So I hope that this 1 hour every day will help me to actually become a specialist in embedded area. But nevertheless, it should be 1 hour every day. So stay tuned. Next video tomorrow, 1 hour, and I hope we'll finish these. Well, as for the plan, let's see. For the plan, I'm planning to finish this circuit. I guess it will work. I hope it will work, and I hope that we'll be moving on to the Wi-Fi exploration. Yeah, so how the ESP32 works with Wi-Fi, and maybe we'll even make the small microservers. So stay tuned. Next video tomorrow. If you are interested, you can subscribe to my Telegram channel, where I post some of my progress and where I post some of my materials, like GitHub like this one, and my notes. So in case you're interested, I will leave a link in the description. You can subscribe and check them out. I'll probably upload the code that I have written today, and the and this beautiful diagram that I have made today. It will be uploaded in like maybe next 10 minutes on my GitHub. So you can check the code and check the diagram. Okay, stay tuned. Say whatever. Stay tuned. Subscribe to my channel. There will be more content. Embedded Monkey here. Bye.